All right, let's now talk about parallel and perpendicular lines. So I'm going to take the same equation that we've been doing in the videos um, on lines here just before. I'm going to make it one parallel. Now, if I want a line parallel to a graph already, then let's see. We had this as the graph went through these points. If I'm going to be parallel, it's got to have the same slope but located someplace else. So it'll have a different y-intercept. So thinking about that, then the equation must look the same, y equals negative 2/3 x, but then with a new y-intercept. Now if it's going to go through the point 4, 2, we'll put in 4 for the x and 2 for the y. If I said make a line parallel to this through this point, that's what I'm trying to do here. I'll have to put in 4 here and 2 here, and let's see what happens. We've got to find b, so that becomes, that's 4 over 1 times negative 2 over 3, so that's negative 8/3 plus b, the 4 is in the x, so there's no x here, 2 is the y, and so I'll add 8/3 to both sides, and 8/3 is 2 and 2/3, so I'm going to have 2 plus 2 and 2/3, adding the 8/3 over here, equals b, so b is 4 and 2/3. So the equation then looks like y equals negative 2/3 x plus 4 and 2/3. And that would be the parallel equation. Now, if I wanted to do use this one and get the parallel, again, the key idea is the slope would have to be the same. It could be located someplace else, but the slope, and that's keyed in this information right here. So that part of the equation would have to stay the same. Negative 2x minus 3y would have to be the same. It would just have a different number here if it's going to go through 4, 2. So if I put 4 in for the x and 2 in for the y, negative 2 times 4 is negative 8. Negative 3 times 2 is negative 6. And that makes negative 14. And that would be the equation of the parallel. Now, is this equation the same as this? Well, I could solve for y to go this way, but how do I go from here to that kind? Well, this has the x's and y's on the same side of the equal sign, so I'd add 2/3 x to both sides, and that would make this be 2/3 x plus y equals 4 and 2/3. And that's almost general form. Well, it is general form, except that it doesn't have integer coefficients. So to get this to be a nicer number, like negative 2 that I had up here, I'd have to multiply this by negative 3, because that would make negative 6/3, which is negative 2. So if I multiply the whole equation, this side and that side, by negative 3, I get negative 2x minus 3y equals, and see, 4 and 2/3, that's 14/3, 12, 13, 14/3. So I'm taking negative 3 times 14/3, the 3's would cancel, and I get negative 14. That matches that. So I change this to this, which is another skill I'm wanting you to be able to do. Go from the slope-intercept form to the general form. Okay? And this is kind of the idea. All right. Now, what if I want to make a perpendicular to this line, but through the point 4, 2? Well, this line had a slope of, the original line had a slope of down 2 and over 3, and it went through some points, and so it was something like this. To be perpendicular, it's got to go in this direction. Now if it's down 2 for 3, this has got to go, this is a negative slope, the perpendicular is going to have to be positive, so I'm going to have to change it from a negative to a positive. And instead of going 2 for 3, it's got to go 3 for 2. So the slope has got to be the reciprocal. So the equation would have to be y equals, instead of negative 2/3, it's got to be a positive, negative, perpendicular, it's got to be positive, and it's got to be reversed, so we got to do the reciprocal, 3/2 x. And what about the -1? Well, the -1 located the original. We're now creating a new line that's in a new location, so we got to find the new y-intercept. If I want it to go through the point 4, 2, that will help us find the y-intercept. By putting in the 4 for the x and the 2 for the y, both sides should come out equal. If that's the case, make 4, 2 on the line. So this becomes 12/2 or 6. And this is 2, so if I subtract 6 from both sides, I get -4 equals b. So the equation would be y equals 3/2 x minus 4. Now let's check, let's do the other one, perpendicular. Now the idea again is that if this is a parallel part, this perpendicular, we have to change the signs. Now this is a fraction, both these are negative. I only have to change one of them to change the fraction and reverse the positions to get that going in the opposite direction and opposite slope. So I'm going to swap the -2 and the -3, so that'd be -3x minus 2y. See how I put the -3 that's in front of the y in front of the x, and vice versa. And then I have to change the sign. So this would still have a negative slope, so I have to change one of these. I'll just change that one. It doesn't matter. It will make a difference in the constant over here. It's got to go through 4, 2, so that's 12 minus 4 is 8. And again, to show that this is the same as that, or that's the same as this, I could solve for y, or I can multiply, move the x over. Let's do it that way again. So I get -3/2 x plus y equals -4. And if I want it to be 3, I'd multiply by -2 on this side. That would make a -2y, and the -2 would cancel the 2 and the negative, and we get 3x plus 2y equal, -2 times that would be -2y equals, and -2 times -4 is +8. And there we go, same equation. So that's the parallel and perpendicular.